Thank you everyone for coming. My name is Dustin Nest. I'm the technical trainer here at StreamNative, and today we're going to be talking about a cloud-native approach to Kafka with the StreamNative Ursa Engine. As I mentioned, I'm the full-time technical trainer here. I'm a chemical engineer by training, but I've worked in software for 7 or 8 years now, in tech support and in training, developing a lot of training content. And I specialize in C++, C Sharp, Java, JavaScript, and React over the years. We're going to go over four topics during this presentation. We're going to start with a quick introduction to the StreamNative Ursa engine. CJ is going to have a much more complete discussion of what that Ursa engine looks like, but I'm going to talk about some of the high-level benefits that you get out of it and why it's important when you're working with Kafka. We're going to talk about Ursa and the Kafka API compatibility. We're going to spend a fair amount of time on the Kafka journey to cost savings with Ursa. And how you can get really a lot of cost benefits there, and then a few more benefits that you get along the way. There's going to be live demos throughout, showing how easy it is to get started with this. Let me start with a quick introduction to Ursa. So the StreamNative Ursa engine seamlessly integrates multiple protocols. So it's going to include both the Kafka API compatibility, and then of course Pulsar API compatibility, as well as other APIs as well. Because it's built on top of Pulsar, it has the unique architecture of decoupling the serving and storage layers. So what that means is you're going to get a highly scalable and elastic cloud-native architecture. And if you are used to using Kafka clusters, you're probably used to over-provisioning, where you have to size your cluster based on what you think your resource needs are going to be in the future. You're going to have no more over-provisioning, which is going to result in a lot of cost savings. You're going to have a right-sized resource at all times, scaling up and scaling down. And then with Lakehouse Storage, you get a large cost savings as well as easier data sharing across your organization. Now that we know a little bit about Ursa, let's go ahead and talk about the Kafka API compatibility. With the StreamNative Ursa engine, we bring enterprise-grade Kafka support for Kafka developers. This includes compatibility with K-streams, K-SQL, K-tables with topic compaction, schema registry for the Java client, Kerberos authentication, and transactions as well. I'm going to start out by going over a few demos. The first demo here is using Kafka and Pulsar producers and consumers on a shared topic. So because we actually use one topic, regardless of if the message is from Kafka or Pulsar, you can share topics under certain circumstances right now, and that would be with string and byte messages when you're using the StreamNative Ursa engine. But what I really want to focus on for the demo is that when you take one of your existing Kafka applications and convert it to connect to the StreamNative Ursa engine, the number of changes you need to make is actually very minimal. We're just going to need to make two small changes. One is to point to the StreamNative Ursa engine, and the second is to change how you're connecting with your credentials. And it's going to be very, very simple with the JWT token or an API key. It's going to be slightly more complicated if you want to use OAuth 2, but we have plenty of examples on how you can do that as well. So now it's time for us to go over and hop into our demo so you can see how easy it is to convert that Kafka application to connect to the StreamNative Ursa engine, as well as what this topic sharing looks like. I'm going to switch over to my IntelliJ here. And here I have what I have called the shared topic project. And if I hop into one of my producers, this is a Kafka producer here. We're going to be producing a message that says published by Kafka producer. And all of this is Kafka code. There's no Pulsar code in here at all. And it references something called topic 1 from our client.properties file. And that's our client properties shared topic file. We're going to be hopping in here a few times during the demo. And we're going to be publishing to a topic called topic shared. Now, I've actually used this exact same code to publish to a Kafka cluster in the past. So here I have a bootstrap server as well as the security configuration. And one of the main things I want to point out here is that when we're producing to the Ursa engine, the StreamNative Ursa engine, instead of the Kafka cluster, there's very minimal changes you actually need to make in your code. For the Kafka producer, there's actually no changes I'm going to be making to this code at all whatsoever. And then in my client.properties file, all I'm going to be changing is the bootstrap server. This is the endpoint to one of your StreamNative clusters that you spin up that has the Kafka API compatibility turned on. And then here in the Sassel JAS config file, All we need to do is go ahead and get a JWT token or an API key. So the JWT token is one of our standard tokens that has a 7-day expiration date, whereas API keys, you can choose an expiration time and they're revocable, and you can have multiple per service account. So really, to get your Kafka code, in this case, just a simple producer, up and running, I've only had to make 2 quick changes. One is the endpoint for our producer and the consumer as well. And then the other is the JWT token gets dropped in. We go ahead and start up the consumer first. It uses the same client.properties file, because the consumer actually takes a little bit of time to start up. The slowness there has nothing to do with the engine. It's just the Kafka consumer. Let me go ahead and start up the producer as well, and we should be able to produce our first message. So here it says it's published by the Kafka producer, and the consumer immediately picks that up, published by the Kafka producer and consumed by the Kafka consumer. Now, one thing that I showed on the slide, I didn't talk about it too much, we'll hop back over there in just a second, is these topics can be shared. So in some instances, like when you have a string message or you have a byte message, you're able to actually share topics with Kafka and Pulsar. There's actually no difference. They're all the same topics. So I can start up the Pulsar consumer as well. So I'm going to have the 2 consumers here over on the right. Actually, here it already picked up that message that I produced with Kafka. I'm going to produce a message now with Pulsar here. So we'll put this on the far left. So it's going to say I produced a message with Pulsar, and then immediately gets picked up by both the Kafka consumer and the Pulsar consumer. And then we started by producing the Kafka message. Let's just produce one more so you can see all of this working again. So here it produced it, and it's consumed by both the Kafka consumer and the Pulsar consumer. So that's just a quick demo of, first, one thing that's really important, how easy it is for you to convert your existing Kafka code to connect to the Ursa engine. And then that was just by making 2 quick changes. The first change was to edit the Bootstrap endpoint, and then the second was the security credential. And in this case, I just used JWT or an API key. You can also use OAuth 2 as well, just requires a little bit more change to your code. And then at the same time, we showed that you can have shared consumers and producers between Pulsar and Kafka. Just to show you a little bit more, I said there were quite a few different capabilities that we're 100% compatible with. Another one is K-streams. So I'm going to go ahead and show a K-streams application working. It's actually going to read the messages that we just published. It's the word count application, and its input topic here is topic shared. That's the one we were just publishing to. And let me close out some of these consumers since we're done using these. And the producer has already finished itself. Let me start up this SN word count application. It's going to be reading from that topic. It's going to be reading the string messages and then summing up the number of times that each word is encountered. So I've actually been running this application a little bit already. So it's, in addition to the 3 new messages that we just published in the previous demo, it's going to add them to some existing data that I already had, because it uses a materialized topic to store that data. So right now, this application, the client is doing the calculation by adding up some of these. And then once it does that, I'll publish another one so you can see exactly how this works. If we just wait a second here, it's going to keep doing the calculation. So it's encountered the word Pulsar 7 times. 1 time is from here. And then the other 6 were from previous times. So if we say published by Pulsar producer, we can say published by Pulsar producer, that would be 20, 20, 7, and 20. It should switch to 21, 21, 8, 21 if we publish another one of those messages. So we go ahead and run that Pulsar producer. So you can see the K-stream application is actually able to consume messages from both Pulsar and Kafka. So here it's received that message, and it's going to start to do the calculation. And again, we expect it to add 1 to each of these words. So 21, 21, 8, and 21. And then that should come up right here. While that's going, I'm going to also start up the Kafka producer, publish 1 more of those. It might get picked up. Yep. So actually, instead of seeing 21, these will all go to 22. This should go to 8 and 14. So here it goes, 8 for Pulsar, 14 for Kafka, 22, 22, and 22. So you can see the K-stream application also works just fine using materialized topics to store the data, which makes it so that when you stop the application and start it back up, it's able to have the existing count from before the application was stopped. And then it's compatible with both the messages that were published by both Kafka and Pulsar, because there's actually no difference. They're both stored in the same topic. The topics are all the same regardless. So that's two quick demonstrations, as well as showing how easy it was to convert an application using JWT tokens by just changing the bootstrap endpoint and the security credential to get in. And again, also OAuth 2 is there. I'm not demoing here, but we also have examples for using schema registry as well, using both tokens or OAuth 2. We go on to the next part here. Now that we've talked a little bit about Ursa as well as Kafka compatibility, we really want to show like why would you want to use Kafka with the Ursa engine? And a large part of that is the journey to cost savings. As you've already seen, you can keep your investment in Kafka code. This is going to require minimal changes needed to connect to Ursa. Again, we showed that that's going to be your JWT token as well as that bootstrap endpoint. And you can keep your investment in the Kafka developers. So you can continue to write applications using the Kafka protocol, or you can switch to using the Pulsar protocol as well for future application development. But how can Ursa help reduce operational costs? Let's take a look at what your organization might look like now if you're using Kafka clusters. Here we have org A using a Kafka cluster, org B having its own Kafka cluster, as well as org C and org D. And you might actually have hundreds of separate organizations in your enterprise, each using their own clusters. This can result in large cost inefficiencies. So you might have a dedicated operations team per organization that's actually embedded in the team, is an expert on the needs of exactly what that particular team needs for that cluster. And then every cluster is going to be inelastic and therefore over-provisioned. So because it's inelastic, it's hard for you to scale up or down your cluster. So when you scale up your cluster at the beginning of your project, you might provision it for resources that you might need from a year from now. So you can be paying for those resources now, but you won't actually be using them for maybe the next year. If you switch over to the Ursa engine, it comes with built-in multi-tenancy. So you're going to have multiple Kafka clusters that get consolidated into one highly resilient cluster that's powered by Ursa. So here on the left, I've shown that org A, B, C, and D are all consolidated into one StreamNative Ursa Engine cluster, or one cluster that's powered by the Ursa Engine. That means you're going to have a single operations team that's going to be working with StreamNative. So you're going to have a lot of cost benefits with a smaller operations team. You're also no longer going to be over-provisioning all of those 4 to maybe hundreds of clusters. That's because the Ursa engine has a highly scalable serving layer that's continuously scaled to the actual usage by your entire enterprise. So you're not going to be paying for all of those resources that you're thinking that you're going to need in a year from now, paying for those today. And then as CJ talked about in his talk, you're going to get lakehouse storage, cost savings, and easier to share data across your organizations. So instead of having data siloed into each org's separate cluster, Kafka cluster, it's going to be consolidated into one cluster, and then your one operations team can facilitate the sharing of data across your entire enterprise between the organizations. I want to show how easy it is to switch over the Kafka producer to use a tenant inside of the much larger StreamNative Ursa engine. So here I have a Kafka producer. Instead of producing to the generic public default tenant and having everyone produce to that tenant and create a bunch of topics that are there, we can separate out different producers and consumers that are in different organizations to have security settings specific to their tenant. I'm not going to be setting that up today, but I am going to show you how you can move the topic or actually switch with the topic that the Kafka producer and consumer are using from the generic public default tenant into one that's inside of a specific organization. So I want to show how easy that is for us to do. So here I am back in the demo. Let me go ahead and stop that word count application that we were working on previously, but I am going to continue to use this shared topic. But I'm going to focus mainly on the Kafka producer and the Kafka consumer at this point. And both of those were using the client.properties shared topic file here. The topic 1 here was the topic shared. I'm going to switch that to org1/demo/topic shared. That's now going to move this particular, or not move the topic, but switch to a topic that's inside of that particular tenant and namespace. Tenant is primarily used for security reasons, while the namespace is where you can group like topics that have a lot of similar policies. So if you want to make sure that there's a large group of topics that maybe need to have the same message retention policies, you would put them all inside of the same namespace, and then I can apply those policies to the namespace. So it's really about ease of management of policies as far as at the namespace level, and security is more, or tenant is more of your security boundary. We go ahead and start up the consumer first again, because sometimes that takes a little bit to start up, but it does use the same client.properties.shared topic file. And I had published some before the demo. So let's start up the, sorry, actually that's the Pulsar consumer. Let's start up the Kafka consumer, because that's pointing to the one that's not in our org one. So here it's starting up the while loop. And then let me start up the Kafka producer here. And it's going to produce into that topic, published by Kafka producer, and then published by Kafka producer, consumed by the Kafka consumer. So we've already, that's all it took. We've already switched over our application to use a topic that's in one of the specific tenants for our organization. And then right now I have security open for this particular user to both public default as well as this tenant. But what this would allow you to do is to now create separate service accounts for different users that only have access to certain tenants. So you've now segregated the different organizations with security, and then you can also further do more configuration to set things like message publish rates and things like that, which would then make your cluster compatible with having multiple orgs inside of one cluster. Let's go back to the slides again. So as we've talked about this, using the StreamNative Ursa Engine allows you to keep your investment in Kafka code. And that was with minimal changes to connect. But now we've showed that you also only need minimal changes needed to use multi-tenancy. And that was just adding the tenant and namespace to the topic definition, and then making sure that your security is set up so the particular user that you're using has permissions in that tenant, which I had already done. You can also keep your investment in your Kafka developers, and they can continue to write applications using the Kafka protocol. So you don't have to hire a whole bunch of new developers that know a different protocol. We also show that you can reduce operational costs by using one single highly scalable cluster powered by Ursa, instead of having potentially hundreds of separate Kafka clusters across your organization. And then because your server is right-sized at all times, there's a huge cost savings there as well as using Lakehouse storage for cost savings and data sharing. Now, before we finish up, I just want to talk about a few more benefits that you get by switching to the Ursa engine. You not only scale the serving and storage layers, but the way the metadata layer works, you can scale to millions of topics to support your enterprise. So even we've talked about scaling storage and serving layers, but actually you have to consider how the entire system, if it could handle everything that it needs to when you move all of your different Kafka clusters into one cluster. And that is possible because of the way the metadata storage layer works. You can also move data across regions or enable disaster recovery with built-in geo-replication. We're actually going to go through a demo of that right after this as well. And then there's flexibility with fully hosted, self-service, bring your own cloud, or a self-managed deployment option. So let's go over just one more demo before we finish up. Here I have an example where I have cluster A, and then I want to do geo-replication to cluster B. This could be either for disaster recovery, or it could be for geo-replication. Maybe you have a bunch of applications that run in another location, and you want to move that data once just to cross over to that location. However, we might have 100 different orgs over here in cluster A, and not all of them should have permissions to cluster B. That would be a security risk. So what I can do is, for one time on cluster A, provide permissions into cluster B. Then at the tenant level, I say which tenants in cluster A are actually able to access those credentials and connect over to cluster B. So it's still at the tenant level that the security is granted. And then you enable geo-replication for all topics in specific namespaces within that tenant. So here it's namespace 1. You can also control it specifically at the topic level as well. So let's go ahead and do a demo here. I'm going to consume some messages from cluster B over here. And we've actually been working on cluster A this entire time. So here I am back in my live demo. I have org1 demo topic shared as my topic. I've already enabled geo-replication. I've given access to the credentials to cluster B at the tenant level and enabled it at the namespace level of demo on my first cluster to send it over to cluster B. So since topic shared is inside of that namespace, that data should already be replicating to the second cluster. Now here in the shared topics file, you can see I have a Bootstrap endpoint, PC2EE. If we go to cluster B, you can see it's actually a different endpoint. Oops, sorry, not that one. Let me scroll down. That's my Kafka endpoint. PC6E4. So that's a separate cluster that anything that's in my cluster B here is going to be connecting to. So let me go ahead and turn on my Kafka consumer in cluster B. And those would be messages that had been replicated over to my second cluster already by geo-replication. Whereas the one here on the left is the Kafka consumer on cluster A. So on the left here is cluster A, on the right here is cluster B. So let me go ahead and produce one more message with the Kafka producer onto cluster A. You should quickly see it show up in both of these. So it shows up here because it's consumed locally there on cluster A. And then this one, it's actually geo-replicated over to cluster B and then immediately consumed by this one. And then if we wanted to, we could also go into the Pulsar producer here on cluster A. And I could change the topic name here to be my other tenant and org, and those messages would get passed across as well. And then there's also the option here to consume the messages on cluster B with Pulsar consumer over there. So again, completely compatible for string and byte messages across both clusters. So actually, let me get, there it goes. Just to summarize, let me go ahead and summarize some of the benefits here. You get to keep your existing investments in Kafka code and Kafka developers. There's minimal changes to use your existing Kafka code to connect to the Ursa engine or to use multi-tenancy, which allows you to then put all of your Kafka clusters into one StreamNative cluster that's powered by Ursa. You're going to reduce your operational costs with a resilient, highly scalable, right-sized at all times cluster. And then we have flexible deployment options of fully hosted, self-service BYOC, as well as self-managed. Thank you, everybody, for listening to the talk. We're going to have time for questions as well, but while we have that slide up, I also want to put up some QR codes. If you want to get started on using your Kafka code with a StreamNative cluster that's powered by the Ursa engine, there's a QR code here on the left. It's a free 3-hour short course. And then also there's a ton of information on our StreamNative Academy YouTube channel that's related to using other capabilities like Pulsar functions, PF SQL, and there's actually playlists on our deployment options for BYOC, as well as private cloud, and also a playlist on how to use our fully hosted option. So thank you everyone for listening to the talk and learning more about the StreamNative Ursa engine and its compatibility, 100% compatibility with Kafka.